Hi, I'm Crystal Eppinger, and I'm very pleased to present my NetLogo project for my System Science 525 class. I am very pleased to present it via YouTube since I am absolutely terrified of speaking in public. I settled on a project which focuses on how or if mindfulness, or what is probably better described as just kindness, impacts the community as a whole. I settled on this project for two reasons. One, I've never actually done a project just to quell my own curiosity, and two, for roughly 8 months, I've been applying some principles of mindfulness to my life, and it's left me feeling a bit more connected to society. So as a person who spent most of her life generally keeping to herself and viewing most other people as, for lack of a better term, a nuisance, I've recently made an effort to bring more kindness and empathy into my interactions with others. So I make certain to wave at people who stop for me on my bicycle, and I smile and I talk more with others on public transportation. And so I'm curious as to whether or not this has any effect on the world at large. Do my kind gestures really inspire others to be kind as well? I combine principles of mindfulness and the concepts of negativity bias to create a toy world to study just this. Negativity bias is the concept that negative interactions have a greater impact on our psychological state than positive ones. So, due to the intensified experience of a negative interaction, we need more good experiences to outweigh the bad. The ratio of good experiences to bad experiences needed to influence behavior is disputed among the psychology community. I settled on a ratio of 7:1 for my project. Since there's a lot of argument about mindfulness and what that actually entails, I think it's more clear to say, I would say that traits associated with mindfulness are present in my model, most specifically the concept of being in the present. My model is intended to look at whether or not kind interactions can overcome the negativity bias of an individual to eventually modify their behavior. And I'm also interested in what initial conditions are required to inspire this change, i.e., how many kind people are required in a community to make this change possible. My model has an initial population of mindful agents and non-mindful agents, which are set by the user. Both agents move about randomly, and when another agent is in their von Neumann neighborhood, they interact with each other. Mindful agents will always have a kind interaction, and their initial breed never changes. They will always be mindful. Non-mindful agents will have one kind interaction immediately following a previous kind interaction, but otherwise will always have mean interactions until their negativity ratio of 7 good experiences to 1 bad experience has been met, at which point they become a mindful agent and they cannot switch back. So I made a number of simplifying assumptions. Mindful agents are always mindful. In reality, not even Pema Chodron, the Buddhist nun, is mindful in every interaction. 2, once a non-mindful agent becomes mindful, it can't switch back. So as we all know, a personality is much more fluid in nature. 3, a kind interaction expires exactly 1 kind interaction in a non-mindful agent. So some kind interactions may inspire multiple kind interactions, and some may inspire none. And interactions are just good or bad. In reality, we place experience in 3 categories: good, bad, and neutral. So the model has an initial population, which is set by the user. The mindful and non-mindful agent population is set separately. Mindful agents are represented by a happy face, and non-mindful agents are represented by a sad face. Once set up in go or push, the agents move about randomly, having interactions with their von Neumann neighbors, and monitors keep track of the population as they change. I'm going to do a little demo here. So as you can see, we have lots of happy and sad faces. I can change the mindful population and the non-mindful population here. We'll do a little change, press setup, go, watch them move about. Not a lot of converts. So as you can see, you start with a low initial population and not a lot happens. So there's some pretty obvious issues with the model based on this implications that tend to skew the results towards a quote-unquote kinder world. It's my intent to add randomness to the interactions of the mindful agents, to allow converted non-mindful agents to switch back, to apply randomness to the interactions that happen immediately following a kind interaction for the non-mindful agents, and also to incorporate neutral interactions. It's an incredible oversimplification, but I do believe that with changes made, it could model the scenario as intended. I can't personally think of any actual applications for the model, but it certainly was effective in satisfying my curiosity, which was one of my motivations for the study. As far as the process goes, I mainly adopted it from Walensky and Rand, and my proposal acted as a guide throughout. What I view as the most important aspect of design is the formulation of my question, and I did this first. It allowed me to abandon a lot of complexity in my initial model, since I realized my question could be answered with a much simpler model than the one I first planned on. I decided on only 2 types of agents, and I chose breeds as my way to differentiate them. Probably could have been done by referencing their properties, but addressing turtles by their breeds allowed me to get the job done with fewer keystrokes. So I made a list of all their properties that each agent would have, and I wrote out a very crude algorithm for their behavior. The coding was pretty easy at that point. I started with the setup and wrote the procedures in the Go program one by one to minimize debugging. All of the groundwork really paid off, and it was surprisingly successful, especially considering I'm a bit of a cowboy with the daily programming I do at work. Verification was very face value, and it doesn't make me a proud scientist. I ran the model very slowly, many times, while varying the initial population to make sure that the behavior was as expected. As far as the validation goes, things are a bit more difficult. Empirical data is my best chance to confirm that the model corresponds to its real-world inspiration. I was thinking of trying to find data and white papers on the negativity bias. I used behavior space to run multiple simulations. I started with an initial population of 5% mindful, and I increased the mindful population by 50 until a maximum of 50% of the population was reached for a total of 50 runs. I ran each population step for 10 ticks, which was considerably more than it usually took to reach equilibrium. Interestingly enough, the results came out much higher than when I conducted them by hand. I'd like to do a bigger run to see what the results look like. In general, the results are about what I would expect. For a small initial population of kind individuals, there are very few converts. And as the initial population increases to about 40%, the jumps in converts become dramatic. And at 47.5%, nearly the entire population is converted. So I really do believe that this data is incredibly skewed, but I also think that with a few modifications, the model could become a fairly accurate representation. I just have to find some empirical data to prove it.